my screen is visible, right? So first of all,
Yes.
yeah, thank you, Karina, for giving me the opportunity to present at OpenShift Commons. Uh, I'm going to talk about LLM-backed Kubernetes controllers today. Uh, to start with, here's something about me. I am Rajas. I work at VMware as a senior member of technical staff. I'm also tech lead at Technical Advisory Group Runtime in CNCF. And I happen to be one of the co-chairs for Cloud Native AI Day, which is going to be a co-located event at KubeCon, this Cloud Native Con, happening at Paris this year. And I'm mostly active in the artificial intelligence and WASM working groups in CNCF, and happen to be happen to be a contributor for Kubernetes. So to start this session, I'll probably start with like some of the myths around artificial intelligence and deep learning in general, and then dive deeper into the topic of LLMs and Kubernetes controllers. So here's a snapshot from course.fast.ai, where Jeremy Howard talks about myths around AI and deep learning in general. And what strikes me the most in this screenshot is how we should not treat AI as a black box. And as domain experts, we should try to interpret AI models in a way to get insights from them, conduct experiments with them. The way AI landscape has been evolving, the blockers around, say, needing too much data to train models or needing a lot of GPUs is something that we can get around. So without further ado, what is this session going to be about? In this session, I'm going to focus on how there exists a gap between domain experts and AI. Domain experts in this case, like Kubernetes engineers, who have fair bit of knowledge around writing controllers and operators on Kubernetes, uh, and how we can take AI models, uh, take leverage AI models, integrate them in say Kubernetes, and go beyond the step of just using them as an API, but also see how they are trained, what is the data used, how we can interpret them, so on and so forth. We'll focus largely on how AI models and deep learning models uh, can very well do the task of decision making and problem solving. But it all depends on what data they use. So there's also a focus on like what data that we're using for training, how we have control over the data, how we have control over the model in general, so that we have insights with like higher accuracy. We'll also talk about how AI can be used for domain-specific tasks, which can be performed with like a fair bit of consistency and accuracy. But that's almost 90% of the task, right? Like it's almost about to fail. What do we do when it fails, right? So there has to be a feedback loop wherein, as domain experts or Kubernetes engineers, we know how Kubernetes configuration should look like or what works well. And if the AI generates an output which is not consistent with the real world, we should be able to provide that feedback to the model and retrain it, fine tune it, make it better and better so that it learns from its mistakes. So that's another area that I'm going to focus on in this session. What I'm not going to focus on is how ChatGPT is, the solution to all of our problems. Talking about ChatGPT, let's dive into the LLMs. LLMs or large language models fairly look like something along these lines. But in the spirit of large language models, we won't dig deeper into this diagram, but pass them more in natural language. So what are LLMs, right? Like at the heart of it, they're just a piece of software that can predict a set of words given a sentence to start with. What these words look behind the scenes are just tokens. What are tokens? So consider a string like this. The model can't pass this string as is. It has to convert this into numbers or tokens. So here there's an example of a tokenizer, which was taken from a model called TextDaVinci, where we are trying to interpret these words as numbers. And then after tokenizing them, this is what they look. If we decode them further, they boil down to words which are not fully formed, but with some of them having spaces, things like that, Peter. So internally, a model parses words along these lines and tries to find patterns around them so that it can predict the next set of words given something to start with. All of this is done using something called as multi-layered neural network. And a neural network is basically a mathematical function which is so flexible enough and has tons of parameter, but it's very dumb to start with. But given an enormous amount of data and using an algorithm called as stochastic gradient descent, we can teach it to predict anything. So in this case, it is predicting a binary dog or a cat string given a picture. So which is classifying between two things. But a neural network, as we've seen in the case of LLMs, can also generate output. So given data, generate more data. So what I'm talking about over here is captured in detail in this hacker's guide to large language models. There's a YouTube link to this, which I can share later. So now that we've talked about LLMs in general, let's move to Kubernetes side of things. Right? From a Kubernetes perspective, everything is a controller at the heart of it, right? Like whether we want to create the plugins, so on and so forth. Internally, there'll be like replica sets, pods, and so on and so created. And then this revolves around the reconciliation loop of getting to the desired state, observing the current state, and getting to the final configuration, so on and so forth. So myself and my co-author of this project, Anil, we thought of combining two aspects of LLMs and Kubernetes controllers, and then we came up with something called as LLM-netes, which is how you can come up with Kubernetes controllers which are backed by LLM models internally. Essentially, what we've come up with is a set of CRDs. One of them is something called as command. The spec of the CRD is just a string which tells do something in English to the Kubernetes cluster. So in this case, it's create 3 pods, and then they'll serve traffic on so-and-so port. And what this controller is supposed to do is parse this in English and then create Kubernetes configuration around it. So we're taking it next step forward and also creating CRDs around cluster audit on how we can say, hey, watch all of these pods and services in my cluster, or simulate chaos around to detect resiliency of the cluster by saying, at this level, try to destroy my cluster and see if it is able to still be resilient enough or not, right? So let me focus on a live demo and try to explain it more in depth. But before I do that, I'll take a pause and see if there are any questions. I'll take a look at the chat as well. Thank you, Adel, for sharing the link to the presentation of Hacker's Guide to LLMs. Okay. So if there are no questions, I can go ahead with the demo. Cool. Let me try to share my screen with the demo. All right. Okay, so this is what the examples of the CRDs that we've written look like, something along the lines of command that we've already seen, wherein the input is a spec, or the input spec is just a string, which is telling the cluster to do something. There's also something called as command exec, wherein instead of just creating Kubernetes configuration, it is also going to apply that configuration on the cluster. So let me get started by applying this command exec CRD. Let's see how that looks. All right. So in this window over here, yeah, this is where my controller is running. So we'll be able to see some logs around it. And I also have a kind cluster running. So if I run this, if I apply this YAML, I should be able to see some Nginx pods coming up. So let me do that. So the controller has kicked in, it is running the query, and internally it is hitting the LLM API, which is the backend of the controller, and generating Kubernetes configuration with this input. Now that the query has been processed, what we should be able to see is some set of pods, in this case, Nginx pods being created. Meanwhile, we can also take a look at what so this is what the output looks like. So in this case, you can see something along the lines of output, which generates Kubernetes configurations for the pod. So the input was just an English string, and then the LLM model behind the controller generated this configuration around it. If I will, okay, the pods are still not up. All right. This is a snafu that we usually see happening. I was not expecting this, but anyway, as of now, the best I can do is show the output that was generated by the model, which was the configuration in itself, right?
Hey, Rajas, you have a quick question. Where's the data coming from that you're using to train these LLM models? What parameters?
Thanks for the question, Karina. So in this one, we're just using an OpenAI API. So we have no control over the data. We're just using an LLM model as an API that we're hitting. To dig deeper into the technicalities of the data, like we have like some more examples which are coming up in the presentation. But as of now, we don't have any control of the data. It's just an API that we're hitting. Does that answer your question?
Yes, thank you.
All right. I'll give another shot to see the pods are up. They're not. All right, I'll move on. Let me start sharing the screen again. All right.
Piotr, do you want to ask your question?
Yes, sure. So, before going to cloud engineering, I understand the way how it works. High level is that essentially it passes to the remote, like OpenAI or any other Llama or other potentially in future other LLMs. Essentially, the query which was in SCR, right? So I could put in a arbitrary queries, and then under the hood, what happens is like there is a specific prompt like return YAM formatted answer to the following query, which blah blah blah, right?
Yeah. That's
okay. Thanks.
So just to add to it, like we're not just generating the query, but or not just generating the output from the query, but also applying it to the cluster back again.
Absolutely. Mm-hmm.
Moving on. So the whole aspects around this is a nice segue to the questions that were asked around the data aspect, right? Is how we should not treat this as a black box, but also dig deeper into it. So let's take a quick look at what I mean by like treating AI as not a black box, right? So this is a snapshot of the ULM-Fit three-step approach algorithm that basically runs behind all of the large language models or ChatGPT in general. And what we see over here is a pre-trained model, which was trained on a humongous set of data from all over the internet. And this is fairly able to complete strings or complete set of sentences. This means that this model has understood constructs around grammar and how to form sentences and how math equations work and so on and so forth. But what we really want to focus on is how we can fine tune it and in general attach data which is much more closer to the task that we're doing. And in general, expect a more refined outcome. The eventual step in this case is how we can classify the fine tuning, wherein depending on the output that was generated by the model, whether the output was accurate or not, whether the output was something that was consistent with the problem or not, right? So this can be done in two ways. One of them being where a human interference is required, wherein the human identifies and tells the model whether the output was consistent or not. Or it can be done by using another model, where the other model tries to train this model in general and then fine tunes it. So these are some of the ways how we can address this problem. But at the core of it, it's more about learning the art of training a model, right? Like how we can develop the skill of training a model. So what I mean by what I mean by that is how we can dig deeper into it. So here's an example of how we took a data set from Hugging Face, and this data set was about kubectl commands. So it had a bunch of columns around a certain objective, command name, commands, and what the description of the command is. So I try to move things around so that the objective can be the context or an umbrella description of that command. And the description serves as a specific question for a particular command. And then the command can be the final output of it. What I mean by that is we can traverse through this data set and then try to extract bits and pieces from it, which can be used to train a model. But how do we train a model, right? So there comes this tool called as Axolotl, which is under the Open Access AI Collective, which can be, so it's an open source tool which can be used to take existing pre-trained models, things like Pythia, Llama, so on and so forth, and then fine tune them with whatever data we want. So in general, not only does Axolotl support a bunch of AI models, but it also supports a bunch of architectures in general. And that is what we try to play around with that. So we use like 8, 10 GPUs in this case, but you can actually, if you have a stronger GPU, you can do it on one GPU, on a single GPU as well. And all that you have to do is just apply the configuration of a particular set of hyperparameters and a particular coming from, like, where is the pre-trained model coming from? So in here, we've used something called as Llama. What sort of data set that we want to rely or fine tune this model. So this is the same data set that we saw earlier. And then a set of hyperparameters that we can fine tune. So things like the number of epochs or the number of times that we should go about this data set. What should be the learning rate? And I don't want to go into the details of each and every hyperparameter, but I want to focus on the aspect of how there are a certain set of things that we as domain experts can learn, in this case, hyperparameters, which we can use to play around with, or experiment with training AI models. So in general, it boils down to something along these lines when you train it. So the entire art of training boils down to how you can minimize the training loss and the validation loss to an extent that it is low enough, but not very low, that the model overfits. What I mean by that is the model only learns what you've trained it on, and is not able to predict accurately on newer data that it has not seen before. So the idea is to decrease the loss, but also do it in a sustainable manner so that it is generic enough to also work accurately on data which it has not seen before. The whole idea around this lies down on how we as domain experts can adopt the skill of training models, and we don't have to learn every math equation or every math construct that goes behind an LLM, but we can learn enough so that we know what should work right and what shouldn't, so that we're in a state to train models and play around with it. So here we trained a model, and to take it further, this is how we can test it out, right? Like, so this is the prompt for this particular model. A prompt is something that you can find with the data set on which the model has been trained on, so on and so forth. So this is a fairly contextual question answer strategy. So given a context and given the question, predict the answer, right? So here we treated the objective as the context and the description as the question, and the command in itself as the answer to it. So this is where I'm going to show two sets of experiments that we carried out. One of them being Tiny Llama, wherein we used a smaller model of 1.1 billion parameters. So you take the model, we've already fine-tuned this with the data that we've seen. We're decoding that, and then we're running it against a query, wherein the objective is to create a job with a command. And the question is, create a job named block processing job using the Redis image, and run the command Redis server version in the created job. So when we run the model against this particular query, this is the output that we got. Now, it did generate a bunch of other things depending on how the prompt reacted. But even though the crux of it was kind of sort of right, but not pretty accurate, right? Like, it didn't generate Redis server over here as a command, as the command to run, so on and so forth. So we tried another experiment by trying Llama, a full-fledged model, and not a tiny version of it. Went through the same churn, and then gave it a query like create a cron job, and then that's the question, and that's the objective, and a question like create a cron job named metric collection using Golang image. The cron job should run every minute and execute the command go run hello.go. The output of that particular query was fairly accurate, something that we can use, right? And then this is where we've tried to play around with it even more. And, the output's kind of sort of right, kind of sort of not there. The idea of this is how we can leverage the skill of fine-tuning models, take the output that works well, and give it a positive reinforcement, while the output that doesn't work well, give it a negative reinforcement, give it a feedback loop back to the model, add this data to the training set, and then fine-tune the model again and again. So this gives rise to an MLOps pipeline that we can generate as part of this, wherein we have control over the data. We have control over what are the hyperparameters the model is tuned on. We have control over the model itself and the output that is generated by the model. The output may not be 100% accurate 100% of times, but then there's a hope that you can fine-tune it again and again, or fine-tune it consistently enough to help with our use case. So that's like the whole aspect around this, right? What we're trying to do with LLM-netes and the controller is to embed models like this, which are like fine-tuned by us, which are not, and create an API around this, but not use direct API models by default, or give the user the ability to get their own models, fine-tune their models, play around with these use cases. And then this gives rise to a bunch of other use cases that open up, wherein right now we're talking about configuration to create pods and cron jobs and so on and so forth. We can take this forward to say upgrading clusters. We can take this forward to say scanning the clusters for CVs and so on and so forth, right? So these are some of the aspects that we are actively working upon. So this is where the code resides. I'll put this link in the chat. This is where most of the development is happening. And this is where this is the place if you want to get involved and play around with LLM-netes or help us, make progress with it, or tell us like, what you like about this or what you don't like about this. All feedback is welcome. So if you want to get involved in LLM-netes, this is the space. And moving on, working group artificial intelligence in CNCF is another area where a lot of collaboration is happening around cloud native and AI. So WG Artificial Intelligence Slack channel on CNCF Slack is where we hang out. Currently, we've been working on a cloud native AI white paper, wherein the focus is on how AI can benefit cloud native and how cloud native can benefit AI. What are the use cases around it? What are the constraints around it? What is the current state where we have to go ahead, where we are at, and all the development that's happening all around the landscape of cloud native and AI. So if you're interested in this area, this is the space to be in. Also, most of this session was taken from the Kubernetes AI and HPC Day presentation that we had at KubeCon Chicago. So this is what I presented with my co-speaker, Amin. That is much more detailed talk on what I've shown over here. And we have a version 2 of this coming up in the upcoming KubeCon, Cloud Native Con in Paris, wherein we're going to talk about all the other things that we're working on, LLM-netes, all the other things that we're working in terms of the concept of LLM-backed Kubernetes controllers, and what lies ahead in the future of cloud native and AI integration. This is all I had for this presentation. Thank you very much. I am open for questions now.
Piotr, looks like you have another question.
Yes, thank you. So for the fine-tuned models that was mentioned, right? So I guess you're building some expertise on that. Are you publishing back those models to, I don't know, Hugging Face or any other open source repos for the trained models for some specific industries or specific domains? Like here we are training, Kubernetes expertise based on Llama, right? So are you pushing it back or not really? Maybe it's not yet mature or something.
Yeah, so thanks for the question. That's the plan. Right now, we're still experimenting with a lot of models and playing around with the hyperparameters, but the idea is to push them back to Hugging Face, push them back to see how LLM-netes can use them, and then publish it out in the open. So that's the roadmap that we are on currently. Thanks for the question. Does that answer your question?
Yes, absolutely. Thank you.
Yeah. Adel, you have your hand raised.
Yep. So thanks for the overview. It's great. I have two questions. Maybe the first or the second one is really a comment more than it is a question. So the first one is, have you thought, so maybe a why question, why are you building LLM-netes on top of Kubernetes and not just like a CLI tool versus a controller? What's the reasoning behind putting it in a controller versus like a kubectl plugin if you want to put it in Kube, for example? I think most of your innovation, I'd say, is in the fine-tuning part and building context and making it context aware for Kube. I'll come to that in my second comment, but yeah, curious about your thought process.
Yeah, so as you rightly stated, like the focus right now is on fine-tuning the models, and embedding them into controllers was like the easiest way to test them and experiment with them currently. Kubectl plugins is what we're thinking about like as a next step, after. So to give you some more context, we're thinking about like how we can get the fastest feedback right now, right? Like how we can play around with things, get the feedback right now, and then play around with like, say kubectl plugins and so on and so forth when it's slightly more nuanced and in shape. Does that make sense?
The reason I was asking is, so for someone to go, they have to understand controller to be able to give you feedback on the context on what you're really trying to do. So this is why I'm asking. So it might be actually easier to start from, because the controller like CRI run the runtime, you have to have that, or people building it manually or whatever. you need to have a controller knowledge to be able to contribute. But anyways, I think I understand where you're coming from. The second part around the fine tuning, I think I like the idea. One of the things that I thought about when you were talking about it was, so one thing that you could do is, so first of all, we have a manual and it keeps in upstream documentation for kubectl on how to use commands, right? One of the things is like that immediately came to my mind were, have you thought about also using just semantic search instead of like really the features of LLMs versus like the whole debate between RAGs and LLMs? It's just searching and indexing documentation and just surfacing stuff up, and then maybe feeding it later to an LLM if really a complicated task needs to be done. But anyways, there needs to be like some human in the middle. Have you thought about like the needs or like melding it before feeding it to an LLM to get some semantic search in between?
Yeah, thanks for that question. So one of the things that has come up in our discussions have been, and talking to a lot of people, has been like the need for vector-based databases or something along those lines, wherein we maintain a state and then pass it to the LLMs. But currently, we've taken the approach of focusing only on the fine-tuning aspect and the LLM aspect. And right, vector databases and something is the next step on the road. But that's a great comment, great question. Thank you for that. And also, I want to go back to the previous question that you asked around the experience around kubectl plugins and things like that. Right? That's a great perspective. Thanks for that. It's certainly something that we're going to consider. Thank you.
Anyways, great work. Thanks for presenting it.
Thank you. Looks like David, you have a question?
Not a question, more of an admin note. I know we've got some good questions on here. So if we try to capture as much as we can in the notes, if we didn't capture your answers, I know there's a couple of them that didn't get typed out. Please go back in the notes and fill those out so that we can capture them fully. We appreciate that, because then that means we have something from the notes standpoint. And Rosas, do the same thing, please, sir, if you can.
For sure, David, I'll follow.
Thank you.
Thanks, David. All right, well, thank you. Are there any other questions? Last minute thoughts? Okay. Well, this is a great topic, and thank you again, Rajesh, for presenting it. We have some good ideas coming out of this on some future topics, so stay tuned. And we'll see everybody next week. So with that, we can go ahead and close out, and we'll see you all soon. Thank you.
Thank you very much, Karina. Thank you.